Hello everyone. This is day 4 of 100 Days of UX, and today we are going to talk about the fourth chapter. Uh, this is digital twin, digital representation of the physical components of your system. Yeah, this was really fun chapter. I actually loved this chapter because it has so many things about machineries and their UIs and everything. So yeah, we will discuss that in detail. But before that, yesterday we have seen one exercise, right? The death clock exercise that we have to do. In that, we wanted to sketch a storyboard. So I will show you my process, like how I did it, and if you have also done that, please share in comments how did you go about solving this problem. Okay. So I will start with my approach. So first of all, when I saw this exercise, I realized that okay, there are so many things we can do with this. So before jumping into the storyboarding, I wanted to just list out the ideas. So I have listed out over here. Sorry for the image quality and everything. Just it is just a quick exercise. I'm doing this daily, so just don't mind about the quality and everything. So yeah, so I did some idea dump that okay, I wanted to explore like what all I can do with this exercise. So first thing first, if you see in the previous one, so they have explored the eating related lifespan. Like if you eat, then you are going to be evaluated on that. But in life we do so many things than eating, right? So there are so many decisions which can increase our lifespan and decrease our lifespan. So I thought like okay, the first thing is eating something. Second could be like, yeah, if you sleep more, if you sleep adequate, then also your lifespan increases or decreases. Then the third thing, that death does not depend on just that thing. It can also depend on how your overall organs are working. If one organ is weak, then that's also not a good sign. You are alive but you are not fully alive. So the one example, if you see that eyes, like we are looking at displays like in the day, like more hours than we are being out on in the nature. So how can you improve your eye health? So there should be an organ clock, maybe, that if you are staring at some place for so many time, then so much of time, then yeah, it should interrupt you in between and tell you that some of the recommendation, okay, you should do this or that. Then also, if you walk for some time, like walk for 10 minutes or more, then you can get some hard points. This example I saw in Google's FitF. If you haven't downloaded, you just you can try it out. You download it, just walk for like 10-15 minutes, and you will see there is a step counter as well as there are hard points. So hard points are basically calculated based on how fast you walk, how long you walk without taking any breaks. So yeah, that could be one of the what you say, evaluation method for your life clock or death clock. Then I was also thinking about, okay, we should clean our houses more often. If your internal, what do you say, that internal dust or something, that if you keep dusting, then your health will improve. But again, like if you see, this was the fifth idea, but I have created like one more idea which was much more related to that, about dust. That if you are going out on a bike ride, so yeah, mostly that will deteriorate your respiration health. So you should wear mask or balaclava or something, so that will help you keep the dust out of your system. So what my point is, see, till here, like I have created five ideas, then this was the 5.1 because it was much more related with that. So this is how you can do some brainstorming and generate some ideas. And stretching and hanging from the road will improve your spine health. So that is one of the thing which I think, yeah, that will also be cool if you give some points to the person, if they are doing such unusual activities sometimes. Then if you take a deep breath, uh, then you get 10 plus concentration in next 20 minutes. So it's like when you are staring at a screen, you are not productive enough. Then I mean, if there is some AI system which can, interrupt you in between and tell you, okay, man, you are not working, just stop, take a deep breath, and then start working again. You will be, in a much more mood and concentration level than what you are right now. So yeah, that idea actually I liked. So in the seventh idea, I really was interested to do some storyboarding. So I have done that, and this is, if you see it clearly, I'll zoom it for you. uh, yeah, see, if the first sketch is about, like, you are staring at something, but you are maybe anxious, or you are not doing any work, you are just tensed, maybe your heart rate is increased, but you are not productive at that time. And this smart glasses prompts you, okay, you take a deep breath, it's needed for you at this time. Then you take a deep breath, and then this, okay, after like some time, maybe a minute after you are taking deep breath, and when you open your eyes, you get some points, okay, you can focus for the next 20 minutes, really good. And then yeah, you are like now feeling good, focused, and you are back to work again, feeling refreshed. So this was my idea. I mean, you can also try, and I'll encourage you to do some more exercises like this. This is really helpful. I really loved it. Then yeah, we'll start with the fourth chapter now. We don't have much time today. So the digital representation of the physical component of system. What is this about? So this is kind of a twin modeling at the exact intersection where UX for AI design can effectively demonstrate that its incredible potential. So there will be some touch points of UX with humans and UX. Um, so AIs with humans, and also there will be some interactions which maybe you want to consume information, or you want to interact with that information. So there is, look, like they have given a beautiful example. So when this is about, like, your wind turbine. So in wind turbine, if you see, okay, there is a yaw angle. What is yaw angle? So suppose wind is coming from my left direction, and I'll show you okay, so the wind turbine's nose is like this. Wind is coming from this direction, but okay, wind can flow from anywhere, right? So you have to, so to get maximum efficiency, you have to, point your nose of that wind turbine towards that wind. So wherever the wind is coming, it should be like this. Okay, so for that, it's not automatic. Okay, this is like a very heavy turbine. It's not like that, toy which we have. So for that, you need some external force, uh, that to point this particular wind turbine in that direction. So how can we achieve that? So they have this 7 motors system, and it is like attached at this base of the wind turbine, which is not like complete base, but yeah, in the middle, if you see, there is a coupling there. So there they have these motors, and that actually, dictates how the wind turbine will point towards. uh, I'll show you like what happens in that time. Okay, now you see, if I zoom this, yeah, first look at how the wind turbine actually looks. This is the nose of the turbine, these are the, blades. And if you see this part particularly, where where you can see these are the motors, okay, 1 2 3 4 5 6 7. So these 7 motors, this is called your system with these 7 motors, okay. And this is like really important to understand that these 7 motors are going to heat up eventually, and their life will decrease once they operate at a higher temperatures. So that's how it works. All the electrical motors, if you like run for a longer time, there are more chances of failure, and their lifespan will be like decreasing. So to understand that, I'll show you one more image. Okay, so this is a graph the author has drawn. So this is showing overheating of the motor. So this is the current it is getting. Okay, this is like an ampere current the motor is drawing from to operate. And if it operates for a longer time, then the temperature of the coil within this motor will increase. And this increased temperature will actually result in decreasing the remaining health, remaining life cycle of this motor. So this so that whole data is actually provided to one of the AI, and that will predict so how long this motor gonna operate, and why we need to know like the lifespan of this. Okay, so I'll show you. So yeah, if you can see this image, so this wind turbine is located in a sea. Okay, it's not easy for engineers or those technicians to go inside this and fix the motors, change the motor, and come. In the meanwhile, this will keep dead and it will not generate any power, and that's not efficient for a business. So how it operates, so if you see, if this if you can get the temperature of it and how much time it is getting operated, then you can actually predict the so this is the conversation of so once you get the data, so they have converted this in a beautiful UI where you can see these are the all like 7 engines. They are calling it engine, but these are like basically motors with some gear attachments. And if this engine like EN4, if you see, the status is ready. But if you see this motor's color, it's red, so it is showing that it's overheating. And this is also showing that this is in operation since 2010. Next planned maintenance was in 2018, and the planned replacement is on 2021. This is the planned replacement. Okay, but how it is operated, how the how energy it is drawing, how at a higher temperature it's going to operate, this planned replacement will might change. Okay, so that is one of the things. So this AI predictor is doing, so this is remotely accessed by the engineers nearby. They can see and they can plan their maintenance accordingly. And yeah, the so if you see the application of this AI, and how the UX is important in this case, it's not just about the UI. It's more about like how you're going to show the information, like how helpful information is that for these engineers or the operators. That is much more important. They should be really aware of what's going on with every engine, and how many engines they can minimally run with. I mean, I have read that like they can even change the direction with 2 engines, like 2 motors, so that's also fine. There is one more thing. So it's not just to change the direction, but sometimes when the wind is coming from the north, and it's like now it's going completely like 180 degrees, and one after 180-degree, so there are some wires and cables within that whole system, so it will twist, right? It can do 180. So I can't like twist my neck 180-degree, because everything will be every pipes and all, every organ will be like gone if I'm doing that. So to reset that, you need some power. So also at that time you need some power source. These motors are required at that moment. So that is also one of the application of this rotational system. Yeah. So I mean, this is like really important to understand that how this you can sketch out the physical component of your systems in a digital way, in a sketch way. This is just a sketch. This is just a motor, this is also a sketch. They have shown this like overheating and everything. So all these components, as a designer, you can show by drawing, by just having images, and just maybe draw a graph, show it to your stakeholders. Then we will see more of how that digital representation works. See, this is a health tracking device. So if you see, This is like they are counting pulse, like the resting pulse, and when you are under exercise, you are under tense exercise, it will also, your calculate your pulse, and then how fast does the pulse go back to normal, that will also be tracked, and based on that you can get your fitness level, uh, because you have like average data for your ages population, and you also feed your age over here, so based on that you can get your fitness level. So this is one level of complexity. Now if you are adding more complexity in this, then you so user is now adding, so these two information are same as earlier, now you are adding age, weight, and your sex. So based on that data, and you are also sharing your GPS coordinates, and number of steps you are taking. So this is all about data. You are adding more data and you are getting more outputs. So now you see how much you need to eat to achieve the fitness goals. So you can define your fitness goals, okay? Then you will get what you need to do to achieve that. How many injuries you have, you are at risk, okay? So if you are running too much, body can sense the water level dropping, and they can warn you before the injuries occur. If you are at a higher altitude, like that there could be some respiration related issues, or maybe blood clotting or something, so they tell you, okay, these are the risk of going to the high altitude, so be aware of that. And if you are walking abnormally, like your one step is like shorter than the other, then also it can sense based on your stride length, uh, and also your lifespan. So all the data will help to uh, you know guess the lifespan, so that could be one of the benefits. Distance plus elevation, calories burned, length of stride. Okay, yeah, this is the phone can measure based on the vibration and everything. Sorry, vibration, and also the sensors the phone has, because phone has like much more sensors. So if you see the first image, it was just a smartwatch. Now in the second one you are adding a phone, and phone can collect everything, all this data from yourself. Then you are adding one more complexity, okay? So what is it? Now you are also tracking the sleep time. So if you wear your watch overnight, and you share your data, uh, like this is the RAM sleep. I think they have added just the RAM sleep in the seventh, in the eighth, in the third iteration. So yeah, uh, it also you are adding basically quality of rest, and your output will be like you know you are also measuring stroke, heart disease, end up in a home, early death, etc. So it's some scary words out there, but yeah, I mean, the more data you input, the more outputs you can get. So all this information just conveyed in a simple sketch. It's like not artsy stuff over here. It's just a visual representation of that. Now they have also given an exercise to do. So now that this is like you have to create, so the exercise in the death clock you have done previously, right? So where you were given one exercise to do, okay? So based on that, whatever you have performed that there, and now you have to create a digital representation of the same, that okay, now how that user's photo, where it will be matched with the database of food images, and then it will be like feed into the image analysis AI, so it will confirm that okay, this is a pepperoni pizza of one serving, and it will be like checked with the nutritional database of the same. So there are also nutrition databases out there, where every item, every food items, calories, and all those nutritions and everything is fit there. So it will check there, it will show you the all the calories and the breakdown of the calories, protein, carbs, and fat, and then it will feed into one more AI, which is called health longevity and longevity analysis AI. So this is the AI they have developed themselves. This is their USP, and they are adding there. Along with that, they are also adding the users data like age, weight, height, and then their cardio exercise related data, then their weight training related data, and the rest and sleep. And then they are actually predicting the immediate impact, that okay, what is your strength, okay, +1 strength, +1 vitality, -1 agility, and also predicted lifespan impact. So how long you are gonna live, it's a predicted score, it's not 100% accurate, but yeah, that's how you can you know you can draw uh, digital representation of your physical components of your system. So yeah, I'll try this, I'll do this exercise and come back in the next video tomorrow. uh, and yeah, we will also go through the next chapter, and we'll continue this journey till we finish this book. Yeah, thank you everyone for joining in. I'll sign off, and bye.